Do for You, The Robot Experiences, Forces, and Motion by Mark Weekland, illustrated by Mike Moran. Welcome to Worldwide Robotics. I'm D4, a helper bot. You can call me Do for You. That's because I do work for you. My partner is HV1 model, but everyone calls him HEV-E1. Workers at Worldwide Robotics build robots. To build a bot, they need to know how and why objects move. In other words, they have to be experts on force and motion. Come into the lab and see our robots using force and motion. They're doing work, so you don't have to. To do work, a robot must move. In his resting position, HEV-E1 is doing neither. The force of gravity is pulling on him. It helps HEV-E1 stay at rest. How will I get him up and moving? Put stinky socks near his smell sensor. An object won't move unless a force acts upon it. Most forces can be thought of as a push or pull. It's force that sets everything, including HEV-E1, into motion. An object's tendency to stay at rest is called inertia. HEV-E1 has a lot of it because he is big and heavy. To move him to a new position, I've got to use a lot of force. Oof! Come on, big guy. Time to power up. Fresh socks. I thought robots were supposed to do the work. A huge robot like HEV-E1 is great at guarding your bedroom. Pesky brothers and sisters simply aren't strong enough to move him. Large forces are needed to move objects with large amounts of inertia. Other objects, such as these crumbs and this dust, have very little inertia. Even a small force, like my brush, will get them moving. While HEV-E1 guards, I clean. Cleaning is all about using force to get something done. First, electric motors apply force to move my arm. Next, my arm applies force to the dirty underwear. Pwing! A lever in action. Simple machines, such as levers, let us do more with less force. My arm and elbow work as a lever. With a lever, I can fling underwear far. 11.5 feet! Whoa! That's a record! All work and no play makes for a boring bot. Here at the testing grounds, robots test objects in motion and have some fun. Every robot in motion used a push or pull to get moving. The robots will continue to swing, spin, and roll until another force acts upon them. This is true of all objects. Danger! Danger! Only another force can make a moving object change its course or stop. When a robot rows down a hill, it picks up speed. Speed describes how fast an object is moving. Acceleration describes how much speed the object is picking up. Gravity is the force that pulls all objects toward the center of Earth. It's pulling on HEV-E1 right now. That's why he's accelerating.
I'm in a jetpack.
The RU-33 robot is accelerating even faster than HEV-E1. Why? The force of gravity is pulling and the force of the jetpack is pushing. In this case, two forces are better than one. Good thing that robot's wearing a helmet.
He's on fire.
Not all forces work to get something moving. Friction works against motion. When two objects slide past each other, their rough parts rub. This rubbing is known as friction. Friction works on skateboard wheels and swing set chains. When there's little friction, moving objects come to rest slowly. When friction is great, moving objects slow down quickly. Dragging a skateboard's tail will slow it down fast. There's a lot of friction between the skateboard and the pavement.
This tail is smoking.
If there's enough friction, the skateboard will stop immediately. Summer is a great time for bare feet, but watch out. You don't want to step on a nail or a rusty piece of metal. Don't worry, with my arm attachments, I will use magnetism to clean your yard. My magnets pull iron or steel objects to them. Ka-ching!
Ka-ching does not register in my hard drive.
Like friction and gravity, magnetism is a type of force. Objects are usually moved with an actual push or pull, but magnets push and pull objects without touching them. That's because magnets use a magnetic field. It surrounds the magnet like an invisible bubble. The magnetic field causes the force that pulls iron or steel to the magnet. Magnetism and gravity are forces that work through solids, liquids, and gases. My magnetic arm pulls metal through the air. The magnet will also work through paper, plastic, and wood. And if Heavy 1 can't get out of the pool, we'll fish him out with a magnet. Magnets attract metal even through water. This is a monster of a fish! Magnetism and gravity are forces that fade across distance. A magnet's pull on metal weakens as the magnet and metal move apart. Gravity is similar. If an object is near the ground, gravity's pull is strong. If the object is high in the air, gravity's pull weakens.
2 for you. The force is with you.
Gravity mission successful.
Thanks for visiting Worldwide Robotics. You've learned a lot about forces in motion during your visit. Now put your knowledge to work. Move an object with a magnet. Figure out the best way to lift a heavy object. Or build a robot that flings you dirty underwear. Remember, robots do your work so you don't have to. Pwing!